Hi everyone, I hope everyone is fine there. Welcome to my channel Data Networking. Today I'm gonna talk about how trace work in MPLS environment. Okay, I'm assuming the audience already know the basic functionality of the trace route as well as the MPLS environment. Okay, because this is normally it is very rare we know about the functionality of the trace route specific to the MPLS environment. I'm gonna focus especially on that particular area only. Okay, and before that, let me select a pen here. Oh, I cannot select. Okay, now I can select it. Okay, in first of all, I'm talking about the trace operation from the Cisco device perspective. In most of the Cisco device, you may be aware of that when Cisco device do a trace route, it always select the UDP port, okay, with some high port number, and then the receiver will receive that particular trace. It will reply with the port unreachable message, and trace will be completed. Okay, but if for example, when the first of router or L3 device uh, decrement the TTL value 1, it will always send the TTL exceeded message back to the source, and it will list its own IP address, and source will able to see, okay, what's the first of device or first of router in the network. So these are the two main uh, type codes in terms in the trace route. Okay, for example, now if we talk about the in general how trace works in the MPLS, remember one thing: when any traffic or any packet coming from the customer device to the MPLS P device or the VRF interface, and this VRF and this P device has to attach some kind of label, what it will do when an IP packet receives as a MPLS label, uh, the TTL value, okay, is copied from IP header to the label stack and decremented by 1. Okay, this is something when the your P device will attach some kind of new labels uh, to the particular IP header. Okay, another thing is when any P router in the core is doing the label swap, it will always again decrement the TTL value by 1. Okay, and will attach the new label. Okay, same is goes with the POP operation, which is basically a pin ultimate hop popping, which is connected to another your respective another edge device. Here also it will once it will remove the label stack, it will always decrement the TTL value to 1 and copy into a newly exposed label. Okay, for simplicity, let me explain how the TTL work in the MPLS, and then I will explain how exactly the each respective device behave in the MPLS core. Okay, now for example, if we have IP header from here with the TTL value of 51, okay, what it will do, your P device will attach two labels. Okay, one is the VPN label and one is the your IGP label, which is the top label. And at what it will do, it will decrement the TTL value to 1 and put the label stack with the TTL value like this, 50 here and 50 here, and push the label into a wire. Okay, now when this P device receive the label, what it will do, it will attach the new, it will do a swap operation, attach the new label, and now it will decrement the TTL value to 1. It won't touch anything onto the VPN label. Push down the packet on this device. This is a PHP router which is connected to your my egress uh, P device. What it will do now, it has to uh, it has to pop this particular label. It has to just remove this label, and when it will do, once the removal will happen, this device will copy the TTL value from my IGP label back into a VPN label. So here the total TTL value will become 48. Okay, and this label packet will reach to a egress P device. It has to clean all the label stack, and then it has to make the decision based on the IP header. Okay, and while doing that, it will again decrement the TTL value from 48 to 47 and copy that particular value inside the IP header itself. Right, before in this operation, as of now, no one has touched the IP header, the initial IP header, because that was the customer original packet. But once the your egress P will make a decision, that decision will be based on the IP header. It depend also the forwarding table of this particular the P device, right? When we always look into when any P device make a decision, even for the customer routes, it decision is based on to the label, and then based on to the IP header. Okay, so this is in general the overview. Now let's consider a scenario. Excuse me, I think yes, this is the topology. Uh, it's the same process which I have explained earlier. Okay, how TTL value decremented into the MPLS core. Okay, now take a quick look here. For example, once a particular, if I'm talking about this trace route from R7 to R8, okay, source is this 7, destination is 8. So in the first row, TTL value will be 1. Okay, okay, fine. This device will it will decrement the TTL value from 1 to 0, and it will just simply send the TTL exceeded message back to the source. So with its own VRF interface IP address. So it will get the first IP information. Okay. Now in the second attempt, it will now send your trace route with the TTL value of 2, trace route probe with the TTL value 2. Okay, fine. It will decrement it to a 1, and now, as I explained earlier, it will copy the TTL value from IP header to the newly imposed MPLS labels, which we can see here. Okay, when we have when we have TTF value 2, now in the IP header, after decrement, I will have TTL value of 1 in the IGP as well as the VPN label. And when this packet reaches to P router in the core router, because this router does not know anything about the customer VRF table or the customer IP routing table. So what it will do here, the two options: either it can simply drop the packet, or it or reoriginate the packet and send the packet to the original LSP path. And this is what the normal in the P router will do here. It won't drop the packet. It will create again after decrement the your IGP label. Okay, it will look into the original IP header, and it see that okay, it does not know anything about this particular source, and since TTL has expired, it has to generate the time exceeded TTL exceeded message. Okay, but how it will do it, that what it will do, it will recreate a complete new packet which is a TTL exceeded. It will put the source address its own LSP interface, or you can say its own incoming interface IP address as a source address, and destination address will be now this particular source IP as a destination address from this P perspective. Okay, and now it will attach the new labels. It will be the same label, but the only difference is that here the TTL value will be 255, and the packet will send to the another P router here. As I explained, because now here it is a PHP process, it will remove the top label, copy down the TTL value into a VPN label. So it will be 254 here, and now once the packet will reach to your egress P, it will now document the TTL value. It will remove the label stack, copy down the TTL value into IP header, and based on the MPLS forwarding inside the VRF, because this P device does not know anything about this particular address, so it will send this packet as an unlabeled towards the your CP device, which is the end device here. Now this device, since no, which is the source address of like it already have the routing information of this particular address, it will now decrement the TTL value 255, send the packet towards the P device again, and the same procedure will happen the way we have seen here. You can see in this particular diagram, and this is the way your packet will reach to the end host. And with the second probe, the end host will able to see the IP address of this particular interface. Now this is the key difference in MPLS. Once we do a trace, it is not like that. If we have TTL probe as a 2 and this router will send a reply back. No, that's not the case, because this router does not know anything about the source address or the customer routing table. So it has to follow the complete LSP path down towards the remote end, and then based on that the trace reply will send back again to the source. It is really not efficient way, because uh, if something is break in the LSP, you certainly will not able to see in which particular link the problem is. For that, there is a different utility which I will cover in a different videos, but this is in general how trace work inside the MPLS. Okay, for example, if as I mentioned here, because the P device uh, does not know anything about this particular um, destination address. Okay, uh, so there are two ways basically the P device will make a decision. One is when as a unlabeled, for example, if there is any BGP route is coming from this device, or some BGP aggregated route is coming from this device, so there will be always two labels in the forwarding table here. One is the unlabeled, and one is that um, one you have no label as an option. In that case, P device, like for example /30, where there won't be any kind of a label attached, their P device itself will reply to a trace route option. Okay, I will explain into the content of my video. So this is I wanted to explain about the overall trace in operation in the MPLS. I hope that video is fine for you and it's a knowledgeable. In my upcoming video I will cover how we can hide the service provider core detail from the end customer trace route. Thank you and have a nice day. Bye.